This is the PowerPoint for Chapter 14 of Sociology 3392, Quantitative Data Analysis. Okay, so quantitative data analysis is the numerical representation and manipulation of observations for the purpose of describing and explaining the phenomenon that those observations reflect. So again, the easiest way to remember this, quantitative generally looks at numbers, while qualitative generally looks at words. So when we're doing our survey research, we're going to be using quantitative data analysis to analyze our data. Okay, so just like your qualitative data, you need to code quantitative data. So the easiest thing is to make a code book. This is a very, very useful document. You're not going to get very far, analyzing your data if you do not have a code book and know what the variables mean. Usually, you're going to be using numerical numbers to make your codes, because that's what works with popular statistic programs such as SPSS, Stata, R, etc. So the codebook also identifies the locations and data items and the meaning of the codes used. So here we have a codebook, political views. Again, it goes extremely liberal to, don't know, no answer. How often do you attend religious services? Again, most of the programs we use don't, recognize words. So we give our words a number instead. So purposes of the codebook: primary guide in the coding process and guide for locating variables. Again, if you don't have a codebook, it's going to be very hard to analyze your data because all you're going to see is, a screen full of numbers with no words that match up to it. So very important to make a codebook. Okay, so again, coding quantitative data, we generally use numbers. So maybe for political affiliation, we say 1 is a Democrat, 2 is Republican, 3 is independent. This works for both, categorical variables, which both of these are political affiliation and region of country. And when we're doing, say we're doing ratio level variables, we'll generally use just the number. So if it's, how many crimes committed in the past year, 0, 1, 2, 3, 4, those are the numbers that we're going to use in the codebook. Okay, so univariate data analysis. You're going to be doing this if you pick the survey research, the quantitative option for your final paper. You're going to be doing some univariate and bivariate data analysis. So univariate, uni means 1. So we're just looking at a single variable for the purposes of description. So we're describing the variables in our data set. So for example, gender, the number of men in a sample population and the number of women in a sample population. Pretty straightforward, right? So what you're going to do if you end up choosing the quantitative project is making a frequency distribution. So basically, that's just the description of the number of times and percentage of the various attributes of a variable that are observed in a sample. So for example, if you're looking at gender, maybe you had asked 100 people, 40 of them were male, 60 of them were female. So then your distribution would be, 40% male and 60% female. All right, a really good way of, showing what your variables look like is by using either a pie chart or a bar graph to show the frequency distribution. So this is definitely something that you're going to want to do if you do choose the quantitative project. This is very easy to do either in Excel, Stata, although you're probably not going to use Stata. I'm sure there's lots of different, software you can find on the internet for free that will do these pie charts or graphs for you. Again, definitely something that you're going to want to do for the frequency distributions of your variables. Okay, so another thing that I want you to do for your final project is the measure of central tendency. So measure of central tendency, a sort of ambiguous term, is the average. So the typical or normal response. So we have 3 different measures of central tendency that we use depending on what our variable looks like. Okay, so the mean. This is the average that's made by computing by an average computation by summing the values of several observations and dividing by the number of observations. So if you have 10 respondents, you're going to add up all those responses and divide it by 10 to get the average or the mean. You do this when you have an interval ratio level variable, also works usually for ordinal variables, and it's not highly skewed. So if you have a normal distribution, if you do not have a normal distribution, you're going to want to use the median. So this is the average representing the value of the middle case in a rank ordered set of observations. So what you do is you rank order everything from smallest to biggest and then pick the value in the middle. So you use when you have outliers or highly skewed data or extreme value. So for example, this is used a lot for income. You will never see anyone say the mean income. If they do say that, it's probably incorrect. We use median for income because there's always a few people out there that, the billionaires are going to skew everybody upwards. So we don't want to really include the billionaires. So we're looking at the middle person in that, if we line everyone up from poorest to richest, we want to look at what that middle person looks like. Because if we add everything up together, for example, I like to use this. Let's pretend that Elon Musk, moved to Lubbock. So did Bezos, and they have billions and billions of dollars. If we were to just add everybody up in Lubbock and, add those two in as well and divide it by how many people are in Lubbock, about 250,000, it would show that we're all multimillionaires, which is unfortunately not the case. So in those cases where we have very, very extreme values, instead of using the mean, we use the median or picking the middle value. Okay, if you have a nominal variable, it's not going to make sense to do the median or the mean. If we want to look at, gender, we're looking at male or female, it's not going to make sense to do that, right? We can't, say that there's a mean number of 1.6 females, or it just doesn't make sense. So instead we use the mode. So this is an average representing the most frequently observed value or attribute. So only use this when you have a nominal variable. So again, this is mode of transportation or travel to work, number of people. By looking at this, we would see that using a car, truck, or van as driver is the mode or the most common way people are getting to work. Okay, another thing that you want to look at when you're doing univariate data analysis is the dispersion. This is the distribution of values around some central value, such as the average. So are they really closely clustered together around that average, or are they more spread out? One thing that you're going to want to take note of when you're doing your quantitative data analysis for your project is the range. So what's your highest and lowest value? So you would calculate it by taking your highest value and subtracting the lowest value. So if your range of income is 0 to 200,000, well then your range is 200,000, right? But if your income is 50,000 to 100,000, well then your range is only going to be 50,000. So it clusters more closely around that median. Standard deviation is a more complex measure of dispersion. Again, it looks at how closely things are clustered around that middle or that average case. So it's calculated to approximately 68% of the cases will lie within 1 plus or minus 1 standard deviation from the mean, 95% within 2, and 99.9% within 3 standard deviations. Again, it just looks how closely those values are clustered around that middle value. It's just another way of calculating it. Okay, so presenting univariate data. A good thing to use is a descriptive statistics table. This is an example of one that I did in a research project. So this gives all the information nicely there. You don't have to spell it out again when you're doing your results section. Just present this table. Again, it will give the baseline, mean, or percent in the case of nominal variables. The M is for mean, the SD is for standard deviation, and then the overall range from lowest to highest. You want to make sure you're really looking at detail versus manageability. How much detail do we need versus how we try to make the smallest amount of data, but the data that we need the most. So if there's something that's not super relevant, maybe don't include it in your descriptive statistics table. Okay, bivariate data analysis. This is the analysis of two variables simultaneously for the purposes of determining an empirical relationship between them. So we're looking at the relationship between two variables, but does not control for any other variables, so no spurious variables at all. So some of our most common types of bivariate data analysis is a correlation, a t-test, and a chi-square test. You will have to do one of these if you are choosing to do the quantitative data analysis project. Which one you use really depends on your research question and the measurement of your variables. So correlation coefficients. It assesses the strength, direction, and significance of the relationship between two linear variables. So you can also do coefficients for variables that aren't measured linearly. You're going to use slightly different calculations, but it's going to look, similar. And you determine whether the relationship is significant using a p-value. So again, we have, there's more to explain for this. So there's a separate video that's posted in your final project folder. This is just a sort of brief introduction to it. So you're going to look again to see if there's a correlation between these two variables. Lots of calculators that you can use online to do so. So it's often the case that you have many, many variables, and sometimes you want to present it more than one correlation for these variables. So in these cases, you would use a correlation matrix. So this is an example from one of my research projects, looking at school victimization and some predictors of it. So what you would do is you would calculate all those correlations and then present them in a table. And it's very, very easy to do if you're using, Stata or R or any of these sort of data analysis software programs. Okay, so t-tests. So there's several different types of t-tests. This is kind of beyond the scope of this class. You're going to learn about this in 3391 if you haven't already taken it. But if you are doing a quantitative project, you will be required to do an independent two-sample t-test for your final project. So this determines whether two groups are significantly different. So we use the sample size, if the sample size are small and we have a linear dependent variable. So again, are we looking at, is there a significant difference in grades for students who study for a test and those who do not? So here we would separate the sample into those that studied and those that do not study and look at those grades that each of those groups got and then see if there's a significant difference. So there's lots of t-tests online. There's lots of calculators. And again, there's a video for this in the folder if you want to do this for your final project. Chi-square test. Similar to the t-test, it looks at two groups and sees if there's, a significant difference between these two groups, but you do them when you have categorical variables. So for example, are women significantly more likely to be sociology majors than men? It would separate this into two groups and looking at sociology majors and non-sociology majors to get at, to see if this is significant. So here again is another calculator and there's another video in that folder. Okay, so bivariate data analysis, guidelines for presenting tables. How you present your table is very important. You want to make it very pleasing to the eye and easy for the reader to understand. Tables are very important when you're, doing submitting to academic journals for your research, because it provides a lot of information in not a small amount of space. So there's always going to be page limits on when you're submitting to different journals. So by having, tables, it has a lot of information in a small space. So a table should have a heading or title that describes exactly what's in it. Original content should be clearly presented, and the attributes of each variable should be clearly indicated. Also, the base on which percentages are computed should be indicated as well. Usually we do this by stating the sample at the bottom of the table. So we'll say, the sample was 900 people. Missing data should also be indicated in the table. You might actually have a separate table for missing data as well, but that's easy to do if, say, you have a descriptive statistic table or a table on your bivariate analysis. It's easy to sort of note how many missing cases there are for each variable. Okay, so finally, multivariate analysis. This is the analysis of simultaneous relationships among several variables. You do not need to do this for your final project at all. I just kind of want to show you some of the multivariate analysis. You're most likely not going to really need this unless you go, into grad school, although it's important to know how to read a table of a multivariate analysis in an academic journal and know what's going on. So multivariate techniques allow the researcher to address issues with facts. So we're able to control for spurious variables and control variables here, meaning that we can control those relationships with the influence of these other variables that we don't get using the bivariate data analysis. So again, I'm not going to explain how to do any of this. If you go on to grad school, you're going to be doing a lot of this, not to scare you. This is a regression table, so we're looking at the relationship between victimization and a number of different predictors. Again, the significant findings are the ones with the little stars next to them, and it gives an incident rate ratio, which is the coefficient that was used because it was a count variable and as well as a standard error. Again, you're not going to need to do this. Just know for this that when you see something like this in an academic journal, that it's probably a regression model. This is another type of multivariate analysis called a structural equation model. Again, it's looking at relationships between variables and allowing to control for other things. So I know for this one that I did, I controlled for demographics as well as a bunch of other things. Sort of looked at the relationships, both the indirect and direct effects of anger, coping, on substance use and violent behavior. So again, you're not going to have to do this. Just, be able to recognize that this is a structural equation model. Finally, ethics and quantitative data analysis. So unbiased analysis and reporting is an ethical concern for quantitative analysts as well as qualitative analysts. So basically, don't make up data. People do this all the time, which is bad. Don't do it. The privacy of subjects must be protected in analysis and reporting. Again, as a researcher, you need to keep that information confidential so that the people cannot, in your study, in your findings, they cannot link people to their answers. Researchers also must report all hypotheses and analysis that were not significant. Having a non-significant finding is just as important as having a significant finding. It tells us just as much. So if we spend all this time, developing a hypothesis and, carrying out all these analysis, and it turns out that there's no relationship between those variables, we still need to know. You can't just sweep it under the rug and say, whatever, it didn't work out. It's still worth reporting.